Hello, people that exist. I have a Newton's Cradle, which, if you didn't know, shows how energy passes through objects in a way. So, potential energy grows as it goes through there, but then the actual energy that goes passes through the balls. Kind of rattled, but everything's stable. Goes between the things. I'm going to do interesting things with this. So, you obviously have just that basic back and forth with one sphere. What if you add a second? Does the same thing, just passes between two. And then, what if you do a third? See, will these two go? Or will it pass through this one? Or will this one move between them? Whoa. So what happens is that the middle ball moves between the others. And then if you do 4, it's pretty much the same thing as doing 1, just the part that's moving is 4 balls. Like that. Which also looks rather interesting. Then, what if you do 1 but have your hand? Makes it get smaller much faster because the energy isn't totally trapped within the balls. That's what moves it here, back and forth. But if a hand is in the way, some of the energy hits the hand. Some of the energy is taken away. And then, well, and another interesting thing is that it stays on a beat. Listen, even as each motion of the pendulum gets smaller, it's still at a stays the same beat, which is because, at least I believe, that the energy and distance have the same ratio. Let's say, for just random purposes, an energy of 2, even though you can't really measure energy like that, and a distance of 3 maybe, I guess. Then the beat would be, I don't know. Well, no. Let's say it's the same. It's a distance of 2 and an energy of 2. So the same thing as it goes even higher. But then the distance goes less. The distance gets less. But the energy also does too. Because some of the energy is part of the swing. But now, it's time for more complicated things than just doing like 4 or whatever. This next section describes more intricate things. Like, let's say doing 2 balls at once, each from a different side. It's just 2 balls bouncing. What if we do 2 from each side? Well, that's a bad example. It needs to be nice and still, but even then it's not the best at staying together. But what if we do 2 and 1? It's an interesting thing where it passes. You can see what's actually happening when you do this. Because it's actually the energy, some of it going this way, some of it going the other way. When you do 2 and 1, you can see that it doesn't just keep bouncing. It's passing between. Like if you watch this sphere specifically, it's moving, and then it's not. So you can see it's passing back and forth. Back and forth. I don't know. But then if we do 3 and 1, I'm guessing it's the same phenomenon, just a bit more scattered. Let's try that again with a bit less energy. Yeah, 3 go one way, 1 goes another way. Means that none of them stay in one position, unlike all of our other expeditions. What if we do like now? Wow, that's really cool. So if you do it on the same beat too, so 1, 2, 3, 4, 1, 2, 3. Too much potential energy. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yeah. Now, let's get into the overcomplicated mess that my brain comes up with. So, this next thing, let's see. What if we move one sphere out of the way completely? Same phenomenon. Kind of makes sense. What if we do 2? Same phenomenon. What if we put this back in? Now it's passing that same way, even though this is starting to go kind of crazy. Let's show that again. So now it's back and forth and back and forth and back and forth. And so now, wait, this is 3 and 2 for some reason. It's just a standard. Weird. Whoa. What if, let me try that again. So it's 2, 2, and you want it to be on the away line that you drop it, so it's coming back when it hits. At least I think so. So boom, 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 boom. That was too much potential energy. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. What if we do this? There. For some reason, this seems far more interesting than just doing what I was, like, which is that. But I want to see what I can do if I... 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Interesting. It either does this or it does this. What if I go crazy and do something like a little stagger? That's ridiculous. What if I just hit the 2? Yeah, the only problem is once you mess this up like crazy, it's really hard to get it back. Oh, and if you stagger that a tiny bit, like 1 and 2, so it's like... Well, that started to follow a beat. What if I do like... So slightly off kilter, which is very interesting. What if we apply, say, magnets? Just a bag of magnets. What if I do, let me think. I don't know. This is just a very interesting science object. And you can see another way of showing that it's the same exact velocity. One of these, or it's the same speed, or not speed, same time. One of them is right here, one of them is higher. Still balances out mostly. Let's try one more time. Success! Goodbye.